Good morning. At this point, we are ready to move on to the second half of our unit. Today's lesson is focused on solving equations. So today, at the end of every single problem, you will have an answer for x or whatever variable is in your equation. Let's take a look at some instructions. The first step, we want the radical on one side completely by itself. So if there is extra whole numbers or extra variables outside of the radical, you need to move those to the other side. Second step, to cancel radicals, we use an exponent. But be careful. You need to make sure you know your opposites. For example, if it is a square root, we use an exponent of 2. But if it's a cube root, we use an exponent of 3 to cancel it. If it's a fourth root, we use an exponent of 4 to cancel it, and that pattern continues. So when you're using that exponent, make sure you look at your equation and you use the correct one. Once the radical is gone, you're going to solve your remaining equation using all of the skills that we've learned throughout the school year, moving things around, combining like terms, distributing, that kind of stuff. What's important is step number 4. There's going to be some problems where the answer doesn't actually work. So we checked answers before. This is another time where it's important. You need to check your answers by plugging them back in to the very, very original problem to make sure that it works. And I'll show you what I mean when we get to some examples. So let's take a look at our first pair of examples together. We need to solve for x. Well, the first step says we need the radical by itself. So I look at this first problem. That negative 10 needs to move. I'm going to move it by adding 10 to both sides. That leaves me with the square root of 2x plus 1 equals negative 5 plus 10 is a positive 5. Step number 2 in our list was we need to use an exponent to cancel our root. Well, this is a square root. So to cancel square roots, we're going to put a little 2 in the exponent on both sides. Well, what that leaves us with, the left side, the little 2 is going to cancel with the root, so we're just left with the underneath, 2x plus 1. The right side, I would hope that you should be able to find that answer. 5 to the power of 2 is 25. At this point, step number 3 says solve the equation we're looking at. Well, this is a very easy equation to solve. We need x by itself. First thing we're going to do is subtract 1 from both sides. That leaves us with 2x equals 24. And then finally, we're going to divide both sides by 2, and we get x equals 12. Here's where we pause because we need to look at step number 4. We need to check this answer. So I'm going to go back to my original problem, okay, before I move the 10. I'm going to put 12 where x is. So let's talk through this. 2 times 12 is 24. If we add 1 to that, we get 25. So we need to square root that 25. Well, the square root of 25 is 5. Then we need to add to it that negative 10. Well, 5 plus negative 10 gives you a negative 5. Is that the answer we wanted if we look up at the beginning problem? Yes, that's absolutely the answer we wanted. That means that this works, and that means this is a correct answer. Let's look at our letter B together. This requires a little more work. We want the radical all by itself. Well, we have 2 different 3's to move. Remember, when you're deciding what to move, always move your added or subtracted item first. So I am going to start by subtracting this 3 from both sides. That leaves me with 3 radical x plus 1 equals 12. Our radical is still not by itself. This other 3 now needs to go away. Well, that's in front, which means multiplication. The opposite of multiplication is division. That leaves us with the square root of x plus 1 equals 4. Now we can move on to step 2. We want to get rid of the radical, so we're going to do the opposite. The opposite of square root is using a square. Just like the first problem, those two cancel. That leaves us with x plus 1 equals, and 4 squared is 16. Now we have a very easy problem to solve. We're going to subtract 1 from both sides. We get x equals 15. Now we got to go back and check. So we're going to put x back up here. So let's start with 15 plus 1 is 16. We need to square root that 16. The square root of 16 is 4. We need to take 4 and we need to multiply it by the 3 in front. So 4 times 3 is 12. Then we need to add 3 to that. 12 plus 3 gives us 15, which is what we wanted up here. We wanted a 15 as our answer. So that means this is the correct answer. So those are one type of problem that you're going to see. Let's take a look at the next kind of problem. A little different. This one, we have two radicals, and they are on separate sides, and they need to stay on separate sides. These problems are actually going to be your easiest. The reason is, we don't need to move anything. You have one radical equals one radical, and we're going to use our exponents to get rid of them. These are square roots, so the opposite of a square root is a little 2. Well, that's going to make both sides cancel. That leaves us with 3 minus 2x equals 1 minus 3x. Now we just want to put everything together that's alike. So I want all of my x's on one side. I'm going to add 3x to move it over here with the other x. That leaves me with 3 plus an x equals 1, because negative 2 plus 3 leaves you with just 1x. I'm then going to subtract 3 from both sides. That leaves me with x equals 1 take away 3 is negative 2. To check these, you're going to have to put the negative 2 on both sides. So this is what we're looking at. Looks like 3 minus, let's write that again, that doesn't look very pretty. It looks like 3 minus 2, then we're going to multiply that by negative 2, and we want to know if that's equal to this side. And this side is 1 minus 3 times negative 2. So let's look at the left side first. If we type this in the calculator, and yes, you may use your calculator, if you type in 3 minus 2 times negative 2, you'll get 7. So we have the square root of 7 on this side. On this side, again, if you type this part in your calculator, 1 minus 3 times negative 2, we also get a 7. Since both sides came out to be the same, that means that answer works. Why don't you pause the video at this point, because B is just like it, and try B on your own, and then pick it up after you're done. So let's check your answer. You should have squared both sides. That leaves you with 3x minus 11 equals 5 minus x. Sorry for the bell interruption. We're going to add this x over here. So we get 4 x's minus 11 equals 5. We're going to add 11 to both sides. So we get 4x equals 16. We're going to divide both sides by 4. That leaves us with x equals 4. Hopefully you plugged it back in on both sides. On the left side, 3 times 4, take away 11, leaves you with 1. And 5 minus 4 also leaves you with 1. So you get the square root of 1 on both sides. So that answer does work. And no, you don't have to show me that the answer works. Just like when we've done this in the past, all you have to do is cross off the answer that doesn't work, and I'll know you checked it. Let's move on to the harder problems. These are harder because there's x's on both sides and they are not both under square roots. So let's look at A. The first step, we need to make sure the radical is by itself, and yes it is. So we're going to square both sides. That leaves us with, after these cancel, 7x minus 10 equals x squared. Now, we've seen problems with x squared before, guys. This is factoring. This is your easy and your GCF and your DOTS and your British. So we need all the stuff on one side, and we need a 0 on the other side. So I'm going to subtract 7x and add 10. I'm going to subtract 7x and add 10 to this side. We get 0 equals x squared minus 7x plus 10. This, if we go through our different types, this is an easy factoring problem because x squared is all by itself. So we are looking for two numbers that add to negative 7 and multiply to positive 10. So we are looking, since this is a positive multiplying number, we are looking for two positives or two negatives. And since the addition number is negative, we're looking for two negatives. So our only pair is either negative 1 and negative 10 or negative 2 and negative 5. The pair that works is the second pair. So we have 0 equals x minus 2 times x minus 5. We're going to set both of those equal to 0. And now we have to solve both of these equations. So we end up with a positive 2 when we add 2 to both sides here. And we end up with a positive 5 when we add 5 to both sides here. But we have to check them both this time. So I'm going to put a 2 on both x's. So on the left, we have 7 times 2. You know what? Let me write this down so you can see it once. 7 times 2 minus 10, and we're hoping that that equals 2. 7 times 2 is 14. 14 take away 10, it leaves you with 4. And the square root of 4 is 2. So those two match up, that answer works. Same thing with 5. The square root of 7 times 5 minus 10, we're hoping that that equals 5. Well, 7 times 5 is 35. 35 take away 10 is 25. And the square root of 25 is 5. So yes, those also match up, which means that is also a correct answer. Definitely more work. You got to remember those factoring tricks that we learned. I'm going to help you get started on B, and then I'm going to have you finish it on your own. Let's take a look at B. So the first step is we need the radical by itself. Well, it's not by itself this time. That's a plus 3 that needs to go away. So we're going to subtract 3 from both sides. That leaves you with the square root of 2x minus 7 equals x minus 3. This is where most students make their mistake. This one's a little trickier. You can square the right side and the left side. But when you square the right side, there's two items there. You have to use parentheses when you square it. These guys cancel to leave us with 2x minus 7. The other side you may not distribute. When you square something, that means write it down 2 times. So at this point, pause the video. I want you to do all your distributing and move everything to one side and do your factoring on your own without my help. And then you can start the video back up to check how you did. All right, let's see how your math went. I'm not going to do anything over here yet. I'm going to do all my foiling. So to help us out, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. combine like terms. We get x squared minus 6x plus 9. Now we need that 0. I'm going to subtract 2x and add 7. Subtract 2x and add 7. So we get 0 equals x squared minus 8x when we combine like terms plus 16. So hopefully you knew that this was easy factoring, because it is. You're looking for two numbers that add to give you negative 8 and multiply to give you positive 16. Hopefully you had it right. It is x minus 4 and x minus 4. Both of these answers are going to be the same, so we only have to do it once. X minus 4 is equal to 0. When we add 4 to both sides, we get a positive 4. Well, we need to check that answer in the original problem again. So you should have plugged it in. I'll write it down for you. Square root 2 times 4 minus 7, then plus 3 outside. We're hoping that that equals 4. Well, 2 times 4 is 8, and 8 take away 7 leaves you with 1. The square root of 1 is 1, and 1 plus 3 is 4. So that absolutely works, and that is the correct answer to your problem. I promise those are the two hardest problems you're going to have in the homework tonight, so make sure that you're good at factoring. Let's look at some other easier ones. We'll backtrack to some easy problems again. These are easy, but if you notice, we are no longer doing square roots. We are doing some other roots. So let's take a look at A. The first step is the root by itself. The answer to that, yes. There's nothing with that radical. We need to use an exponent. Here's what's different. This has a little 3. So we're going to use a little 3 to get rid of it. These two cancel. That leaves us with 4x minus 5. 6 times 6 times 6 is 216. Now we have to do our regular solving. Add 5. We get 4x equals 221. We then divide by 4, and we get x equals 55.25. So we need to plug it back in to see if we get the right answer. So cube root 4 times 55.25, take away 5. And we want that to hopefully give us a 6. Well, 4 times 55.25 minus 5, put all that in your calculator one time, that gives you 216. And you're going to use the cube root button. The cube root of 216 is 6, which is what we wanted. So that answer is correct. Once you pause the video, try B on your own. Start it back up when we're done. All right, so let's see how you guys did. We need to move this 3, so I'm going to subtract 3 from both sides. That leaves me with the fourth root of 5x minus 9 equals 11. I can't subtract. It's not 11, it's 5. Sorry. We have a fourth root, so I need to use a fourth power to make these guys cancel. That leaves us with 5x minus 9. If you put in your calculator 5 to the power of 4, your calculator will tell you 625. We are now going to add 9 to both sides. That leaves us with 5x equals 634. And then we are going to divide both sides by 5, and that gives us 126.8. All you need to do is check your answer. So if you put this back up here, you use your calculator, 5 times 126.8 minus 9, your calculator will tell you that's 625. If you take the fourth root of 625, you get 5, and 5 plus 3 is 8. It did work. So hopefully radical equations you're feeling pretty good with. We're going to look at the other kind of equation today, and that is rational equations. These are all going to have exponents. Okay, they're going to have exponents that are specifically fractions. So, as the directions say, we want to get the part with the exponent by itself, just like the radical. This time, to cancel out a exponent, we use the, and this is important, we use the reciprocal exponent. So, for example, if the starting exponent was 1/2, we would use 2/1. If the starting exponent was 3/5, we would use 5/3. Hopefully you understand what I'm explaining there. Then, whatever is left over, you're going to solve for x, just like with the radicals. And yes, you need to check your answers again to make sure they work. So let's take a look at an example together. So, as you can see, we have an x that has a power of 3/4, and it's equal to 27. Well, we don't need to move anything. We need to go straight to using the reciprocal exponent. So what I'm going to do is on this side, I'm going to multiply by a 4/3 in the exponent, and I'm going to put a 4/3 in the exponent over here. Well, on the left side, it all cancels. We have x left over. On the right side, you need to know how to use your calculators. If you are using one of my yellow calculators, you would type in 27, hit your caret button, then 4 divided by 3. My calculators are special though. If you're using a calculator at home, the most important thing you need to know is that you must use parentheses there. So any calculator you have at home, you're going to do 27, you're going to hit your exponent button, parentheses, 4 divided by 3, close parentheses, and you'll get an answer of 81. All we have to do to check that is put 81 where x is. So 81 to the power of 3/4. Type that in the calculator the same way you just typed in the last line. 81 to the power of 3/4 does give you 27. So 81 is the correct answer. Try and pause the video now and attempt B on your own just to see if you can get the right answer. All right, let's see how you did. So we needed to use a reciprocal of -3/2. Well, that's 2 over -3 on both sides. This stuff cancels. That leaves us with x. In your calculator, you're typing in 729, exponent button parentheses, 2 divided by -3. Now, you're most likely going to get a decimal. We don't like decimals, and you're not allowed to round. So you need to, if you're using one of my calculators, math, enter 2 times, and it would tell you that x is 1 over 81. If you type that back in the calculator, you're trying to do 1 over 81 to the power of -3/2. What's important is that needs to be in parentheses, and so does that, in order to get 729. And yes, you will get 729. So that is a correct answer. Let's look at one more, and then you're going to try one on your own again. Let's look at example A together. So we need to get that 3 going. So I'm going to start by dividing both sides by 3. That leaves me with, in parentheses, x plus 1 to the 3/5 power equals 8. I am going to use the reciprocal. So I'm going to do 5/3 and 5/3 on both sides. That stuff all cancels. When the exponent's gone, you can get rid of the parentheses also. So we're left with x plus 1 equals, in your calculator, 8, exponent button, parentheses, 5 divided by 3. If you type it incorrectly, you should get an answer of 32. We're then going to subtract 1 from both sides, and we get x equals 31. If you go to check your answers, you can do the left side, 3 parentheses in your calculator, 31 plus 1, so like if you want to do this all at one time, 3 parentheses, 31 plus 1, close parentheses, exponent button parentheses, 3 divided by 5. If you type all of that in one time, which is fine, you should get an answer of 24. So that answer works. Go ahead and pause the video, and then I want you to try this one on your own, and we'll start back up to check your answer. Let's see how you guys did. We're going to start by adding 1 to both sides. That leaves us with 27x to the power of 3/4 equals 27. We're going to use the reciprocal, so 4/3 on both sides. That makes a bunch of stuff go away. That leaves us with 27x equals, and you're typing in the calculator 27 exponent 4 divided by 3. Hopefully, if you type that in correctly, you should get an 81. Divide both sides by 27, and you get x equals 3. If you type the whole left side in your calculator, it would look like this. 27 times 3, close parentheses, exponent, parentheses, 3/4, close parentheses, minus 1. If you type all of that in your calculator at one time, you will get 26, which means this works, and this is a proper answer. So this is definitely a tough lesson. Hopefully you maybe had to rewind, check things over again, watch it a couple of times. At this point, you might want to maybe try a couple of your homework problems just to get started. But again, you will have time next time I see you to complete it in class.